For this lesson, you are going to need a standard graph sheet like this one. So if you have one by you, quickly grab it so you can follow along practically. Practice makes perfect, they say. Alright, now let's get into this lesson. Someone might be asking, why are we plotting graphs? Why are we plotting points on a coordinate plane? Graphs have applications, okay? Real life applications. And as we continue on with the lesson, I will chip in some practical questions that will help enhance your understanding on the applications of graphs. So you just relax and follow along. Do you understand? As we move on, the practical applications of graph work will unfold to you, okay? So this time around, we are not going to plot on the previous coordinate points. We are going to use your graph sheets, okay? So if you have your graph books or your graph sheets with you, follow me and let's do this, okay? So the fuel consumption of a car is shown in the table below, okay? So the amount of fuel that a car uses, okay, as it travels. So the fuel consumption is measured in liters L, and then the distance that it covers is in kilometers. Are we okay? It's in kilometers. Good. So when the car travels a distance of 20 kilometers, remember the units, 20 kilometers, it consumes or uses a fuel of what? 2 liters. Okay? And after it had traveled a distance of 40 kilometers, it had consumed what? A fuel of what? 4 liters. Okay? And so when it travels a distance of 60, then plus another 2 liters, right? 6 liters. Then another distance of 80 kilometers plus 2 liters, 8 liters. So you can see here that the consumption, okay, measured against the distance gives us a constant value, okay? This increases by 2 liters for every 20 kilometers distance the car travels. So it is constant. Good. We are to show this information as a graph, okay? And it is very simple, very simple. So to show the information as a graph, write the corresponding values in the table as coordinates. These values in the table, write them down as coordinates. See, remember how to write out coordinates? Yes. That is why I made us do some exercises when we began, okay? So, solution. We take these values to be on the x plane. These values to be on the x plane. And then we take these values to be on the y plane. Okay, so if you have your pencil, you can label here as x and y to guide you. Get what I'm saying? Yes. So normally this is taken as to be on the x plane. This is taken as to be on the y plane. And so writing out the coordinates I, we have 220, 220. Then we have 440, 440. Then we have 660, 660. We have 880, 880. Then we have 1000. So 1000. Okay. Now we are going to plot these points on a graph sheet. But before we plot these points on a graph sheet, we also need to choose a scale. Okay. So looking at this, okay, we can choose a scale where on the x-axis, how many items do we have? 1, 2, 3, 4, 5. We have 5 items, right? And so let me shift the graph book so that you can see what I am doing. Okay, we can decide to put our origin or our 0 here. Okay, and then we have 5 items, isn't it? So when we put our O here, how many items can fit here? If we take this full box, we can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 items can fit here, right? And so we can distribute the 5 items across these spaces. Okay, in order to enhance clarity, you get what I'm saying? In order to have a more neat and clarified work, which is not clustered. Each square or each full box measures 2 centimeters. Each square, each full box measures 2 centimeters. So from here to here is 2 centimeters. From here to here is 2 centimeters. Likewise, you see, it is a perfect square. Okay, so likewise, from here to here is 2 centimeters. From here to here is 2 centimeters. So on the x-axis and on the y-axis, each square or each full box measures 2 centimeters. Okay, and in between each full box, okay, measures 1 centimeter. Obviously, half of 2 is 1, and so here is 1 centimeter. And then from here to here is the full 2 centimeters. Okay, so on the x-axis, I choose a scale of 2 centimeters. That is 1 full square, 1 full box, and I give it a unit of 1. That means when I put my 0 here and I choose 1 full square or 1 full box, I'm going to give it a unit of what? 1. 1. From here to here, because the difference is 1, here will be what? 2. Then from here to here, 3. From here to here, 4, 5, 6, 7, 8, 9, 10. Remember, there are 5 items, and the largest number is 10. Okay, and so when I choose a scale of 2 centimeters to 1 unit, I can still get to 10. You have to do it in such a way that the items and the corresponding largest number fit. If the largest number here were 12, okay, if this was 12 instead, and even if I can distribute the 5 items here, the largest number will be 12 and not 10. And so still I'll be found wanting. And so I'll then need to change my scale. Are you with me? Good. So 5 items, largest number 10, it fits perfectly. The y-axis, how many items for the y-axis? 5. Okay. And I choose to number it 10, 20, 30, 40. So what am I doing? I'm giving it a difference of what? 10. So each full square or each full box is 2 centimeters, isn't it? So 2 centimeters is to what? 10 units, because I am counting in tens. Just like over here on the x-axis, I counted in ones. Here, I am counting in differences of 10, or I am counting in tens. Okay, so 2 centimeters, 1 full box is to 10 units. So 0, here will obviously be 10. Here will be 20, 30, 40, 50. Now, the next thing to do is to label my axis. Very important. You lose marks when you don't label your axis. And so you realize that for the coordinate systems that we did previously, all the axes were labeled. That's some of the very first things you do. Okay, you lose marks when you do not label your axis. So there's the y-axis, this mine, x-axis. Okay, I'm trying to squeeze the x-axis here. Now, not only that, the y-axis and the x-axis, they both represent something. And so you would have to indicate what they represent this time around. In the previous question that we did, we just had some points and some coordinates, right? So x-axis, y-axis, x-axis, y-axis. We were not told what they represented. We were only just learning how to what? Plot graphs and interpret them. But for here, the x-axis and the y-axis represent something. The x-axis represents, you remember, fuel consumption. Fuel consumption. And the y-axis represents what? Distance, measured in kilometers. The y-axis represents distance. And the x-axis represents fuel consumption. And so after labeling your x and y-axis, you need to write what they represent. And so I'm going to try to squeeze it here. Okay, so fuel consumption, right? And distance for the y-axis. So as you can see, because I couldn't fit it here, I just wrote it here, distance for the y-axis.